Hey everybody, Mr. Markwood here again with you. Welcome back from winter break. I hope you all had a nice couple weeks off here. Got a chance to recharge your batteries a little bit as we make that final push towards the end of first semester. So now that we're back, I'm going to start with some announcements because we got a lot of stuff happening in Algebra 1 as we wrap up the semester here. First things first, at the top of our announcements list, we have our Chapter 3 test this upcoming Wednesday, which is 2 days from today when we should hopefully be watching this video and working through Lesson 323. So make sure we're going to be studying for that. So what's on that test is going to be exponent rules and laws, so like raising things to negative exponents, simplifying expressions with exponents, all that kind of good stuff, and then solving equations. So we're going to have a review sheet posted tomorrow for you to work through that will get you ready for that test. Speaking of tests, we have our final exam. So this first semester exam is a week from tomorrow. So Tuesday, January 12th, in class, we are going to be doing our final for first semester, so you can look forward to that. And again, the end of the semester is next week, Friday, so make sure if you are missing homework, quizzes, any sort of tests, that we get that stuff done as soon as possible because we are very, very quickly running out of time to do that. So that being said, a lot of stuff going on. If you have any questions or are kind of confused about what you're missing, or if you need to get stuff turned in, please reach out to your grading teacher, whether that's me or anybody else on our Wonderful Algebra 1 team. But please let us know if you have any questions. Again, we're happy to help you as we make the final push towards the end of first semester. So today we are going to talk about multiplying binomials and the distributive property, lesson 323, and we're going to jump right into that here. So 323 and lesson 322, way back before winter break, like almost 2 weeks ago, we made rectangles with algebra tiles and then found the dimensions of those rectangles. So we started with the area of a rectangle as a sum, and then we wrote the area as a product. So today we're going to do that in reverse. So we're going to start with the product and find the area as a sum here. So we're going to start kind of a little review in 354, and then 355 we're going to basically do what we did way before Christmas and kind of do the same thing in reverse. So as we start with 354, for each of the following rectangles, find the dimensions, the length and the width, and write the area as a product, and then write it as a sum. So this is exactly what we did last week, or 2 weeks ago now, before Christmas break. So let's do part 8 together. I'll let you guys all be on your own for a little extra practice. But as a review, when we find the length and the width of a rectangle, if we call, let's say, this side let's call that our length, this side would be our width, and we do that because we know the area of a rectangle is length times width. So knowing that all of these tiles inside of the rectangle are algebra tiles that we practiced making, let's see here, on the 22nd, so a way long time ago, we know what the areas if we add all those together, but we also know the side lengths of those algebra tiles. We've been talking about that a bunch in class lately. So let's first go through and label the rest of these algebra tiles by their names. So we have this other big tile is an x squared tile. These tall skinny ones are all x tiles. These long skinny ones on the top are all x tiles as well. And then again, we know that those short little squares are all our unit tiles that are equal to 1. So let's start by finding our length. So again, we know the side of all 4 sides of our x squared tile are all equal to x. So that side is going to be x. And the short sides of our x tiles are always equal to 1. So we have 1 and 1. So if we want to write an expression to show the length of that side, we would just add all 3 of those things together. So we'd have x plus 1 plus 1. We can combine those ones. So this would look like x plus 2. And now we can do the exact same thing for the very bottom here. So on the bottom here, we have 2 x squared tiles. So we have this side length is an x, this side length is an x. And again, the short sides of our x tiles are always equal to 1. So we have 1, 2, 3 x tiles with 3 short sides showing. So we have this side would be equal to, again, we have 1, 2 x's, and we have 3 unit sides showing, so 2x plus 3. So now if we want to write the area of that rectangle as a product of, like the product of those 2 things together, we could say length times width in this case is, let's see here, it's 2x plus 3 multiplied by x plus 2. And then if we add We're going to find the area of this shape just by adding all of those algebra tiles together. So the area as a sum. And put that in green down here. Okay, so we have 2x squared tiles. So we have area equals 2x squared. We have 1, 2, 3, 4, 5, 6, and 7 x's. And then lastly, I think we have 6 unit tiles. So again, because those are both equal to the area, we can say those things are equal to each other. So basically what we're saying by that is 2x squared plus 7x plus 6 is equal to 2x plus 3 times x plus 2. And that's a little review from what we did from last time we met before Christmas break. So let's do the same thing but in reverse. So as we go to 55 at the bottom part of our page here, we want to look at these expressions and build the rectangles based off of what we have. So if we had the link for that e-tool, that might be a useful thing to pull up as we're working through the lesson today. But we want to look at these two quantities and figure out what the rectangle that represents that is going to look like. So for A, let's say that this first chunk in parentheses is our length, this second parentheses is our width, and again, knowing that area is length times width. If we look back to what we just did on the last page here, so we know if it's a side length of x, it has to be an x squared tile. If it's, a side or on the side length is a 1, it's probably either an x or a unit tile. So we have to kind of match those up with the tiles that we have on the right side of our screen here. So again, x plus 3, it tells us that we're going to have 1x and then 3 unit tiles stacked up on top. So that would be our length in this case. For our width, we've got 2 x's, so it'd be something like x, x, and then we've got 1 unit tile off to the side. Now we just kind of got to fill in the blanks here. So we know that the only thing that has side lengths of x is either our x tile or our x squared tile. So our x squared tile, I'm going to put this down here. I think I drew my stuff a little too close together, so let's do x and x, and then plus 1. So x squared. So that satisfies us in the corner. We've got a side of x, works for an x squared tile, we are good to go. So on the bottom here, we have another x next to it. So that's either going to be an x squared tile, which I forgot to copy that. So that would probably be something like this. So far, so good. We have those 2 x squared tiles on the bottom left-hand side of our rectangle. So if we want to finish our width at the bottom part of that rectangle, we have to make that side either be a unit tile or an x. So let's start. We know that all 4 sides of our unit tile are going to be an x, but I don't think that looks right. Right? Because we know that this side, the tall side of our x is equal to x, or if our x squared tile is equal to x, this unit tile is not x units tall. So let's maybe get rid of this one for now. And let's try it with one of our x tiles and see if this might work better for us. So if I slide this around, perfect, that's close enough. All right, so we got our side length of x, side length of 1 on the bottom, so we have 2x plus 1 on the bottom, that's our width. So far, so good. So next, we have to finish our length, which is the left-hand side of our rectangle here. So we have to add 3 more tiles going up that would represent that width. So again, if we try this with just adding a unit tile up here, I don't think that looks exactly right, because as we know from the past, we worked with our unit tiles. If we try to stack this up on top of our x squared, they don't line up super nice. We have to use something that has the same side length as an x squared tile, which again would be our x tile. So if I can click and drag one of those over, perfect, we've got a side length of x. On the left-hand side, we've got a side length of 1. So maybe let's try stacking 2 more of those up. That's going to get us pretty close. And let's do 1 more. So again, now we just kind of fill in the blanks here. We got x, we've got 1 unit 2 units and 3 units for the size of those X tiles. And now we just got to fill in the rest of that so it looks like a rectangle. So I think since we have another X squared tile, we have to stack up 3 more X tiles to fill in the blank. Otherwise, it's not going to be a consistent looking gap here. So let's do just that. Perfect. Let's slide this one over just a little bit more. Again, this is going to be close, but not exact. That's good enough. Perfect. So then we're almost there. So now everything left has the length of 1, right? So these are going to be spots for our unit tiles over here. So if we add and fill in the blanks here with our unit tiles, we have 1, 1, and 1. Perfect. That looks like a rectangle now. So we've got, again, our length or width on the bottom is, like we can see, is we have 2x's plus 1. So 2x plus 1. On the left-hand side, we've got x plus 3. And there we go. We just went backwards and built ourselves a rectangle. And now if we want to write the area as a sum, so again, I'm going to erase this real quick. What we can do is, again, set this top quantity equal to the area as a sum, because they're the exact same thing. So we just got to add all of those x tile or algebra tiles together in the middle here. So we've got an x squared and an x squared. So that's 2x squared. Next, we got to count how many x's we have. We've got 1, 2, 3, 4, 5, 6, 7 x's. And we've got 1, 2, and 3 unit tiles. Perfect. And then we just work backwards. We got the exact same thing. So x plus 3 times 2x plus 1 is equal to 2x squared plus 7x plus 3. We're going to get more on how to do that this coming week here, so we can look forward to that. But there we go. We just built our rectangle from scratch using our length and our width. Let's try one more, but let's use one that has x's and y's this time. So we have x times the quantity of 2x plus y. So again, let's break this into parts that we know. So for an area, it has to be length times width. So it has to be area equals length times width. Let's say that x, that one only x out in front, is going to be our length. So our width is going to be 2x plus y. So that means that our side length going up and down for this rectangle has to be an x, because that's what our length is. So there's 2 options for us. We can either have an x squared, or we can have just a regular old x tile. Those are our 2 options for things that have sides of x. Actually, sorry, there's one more, and that would be our xy tile. So let's try to experiment with those 3 things here. So we know all 3 of these things have a side length for x, or a side length of x, so they are all contenders to be our length, or our building block, for our algebra tile. So then next we have our width, which is 2x plus y. So again, if we kind of draw this out so we know what this kind of looks like when we break down our side, on the length is going to be is x. Then on the width, we've got x, x, and y. So looking at that, whatever tiles we use to fill that in, I don't see any unit tiles or any constants in there other than the fact that's telling that we have 2 x's for our width. So that tells me that this x tile is going to be not very useful to us because it has that short side of 1, and we're dealing just with variables in this problem here. So now, if we have 2 x's on the bottom, so let's maybe use our x squared tile as a reference here. So we've got, again, our side length of x. We've got our side length of x. So going off what we just kind of drew up on top here, what else do we have in our little diagram here that has side lengths of x tall and x on the bottom? That's going to be, I think, another x squared tile. This is the same height, same width, so it's not going to look any different other than we're just doubling the width at the very bottom. So again, here we're still good because it's the same height. This is our x. And now we just got to figure out how to add a y to it. So what is a y, or a tile that has a y in it and an x, whereas the height of a y and the width of a y tile, or the height of an X and the width of a Y. I think that's going to be our XY tile. So it would be something like this, where again, this length over here is X, that side length is Y. So if we look at our length and our width, we just have our length of X, all three of these things together add up to be our width. So again, that is 2X plus Y. So now I think we correctly drew our rectangle, and now we can write our area as both the product that we have given to us and then our sum, which if we write this in the sum, we've got 2x squareds and an xy. So we can say that 2x squared plus xy is our area as a sum, and that can be equal to x times 2x plus y. So again, there's quite a few more of these on our page. I would say for sure do B and D as you work through today's lesson. Take a look at the next page for E, F, G, and H for some more practice if you want a little extra, which I would recommend because this is kind of an important thing as we're building up to here. So let's see here. Last thing we're going to talk about in the video for today is 56. So as we look back at B and C, which we didn't do B, but we did do C, this pattern is called the distributive property. So what that really means, if we go back to D, or C I should say, so when we see our final answer is 2x squared plus xy, we have x times 2x plus y, what that distributive property is really telling us is that we are taking this value out in front and we are multiplying each number inside of our parentheses by whatever number is out in front. So we're distributing that number through the parentheses exactly like we did when we were distributing our negative signs into our parentheses trying to solve equations. It's the exact same type of concept. So if we do this one with A here, let's do A and C together for a little practice. So we've got, again, 2x is this quantity out in front, and we want to multiply both of the things inside that parentheses by 2x. So we take 2x, multiply 6x by it, and then multiply 5 by it. So first thing is going to be 2x times 6x, and we are adding 2x times 5. So again, we only multiply the things together that are the same. So in this case, it's the constants or the x's. And the same thing with the second term, so we only multiply the constants together. So if we have x, so let's see here, let's start here. 2x times 6x. So we've got 2 times 6 is 12. We've got x times x. So again, that's our exponent rules. X to the first times x to the first. We add those together. So this is going to be 12x squared plus the second term. We can only multiply the things that are the same, which again are the constants. There's not x's in both terms, so the x stays the same. So here we are left with 12x squared plus 10x. All right, so let's try one with variables, or with two variables. So part C, so again, we can only multiply things together and make it into a squared if they are the same. So again, it's just following our exponent rules. It has to have the exact same base in order to multiply those things together. So when we look at part C, we have our outside quantity is 3y. So we have to multiply everything inside the parentheses by 3y. So again, we take 3y, multiply that times 4x times 3. So what that turns into is 3y times 4x plus 3y times 3. So again, we can only multiply the things together that are the same and change it. So for example, 3 times 4 gets us 12, but we can't multiply y and x together without knowing what those variables are actually equal to. So this would turn into 12 times xy. And then adding on to that, 3 times 3 we can change. We know what that is. So 3 times 3 is 9. There's nothing we can do with that y. So this answer would be 12xy plus 9y. So again, what we're trying to do is just multiply whatever is out in front. We have to multiply both terms on the inside of that parentheses together, and then we will be able to get our final answer like we have in A and C. So try B and D on your own, put the answers in the filled in notes, and then we should be all set. So again, the end of the semester is coming up next week Friday. If you have any missing assignments, please reach out to your grading teacher. Ask any questions, find out what you're missing if you don't know, but we're running out of time, so let's get cracking on some of that stuff. Otherwise, again, welcome back. Glad to have you back as well. We'll see you all soon. So have a good day, everybody.